Well, welcome to the Haimer stand, MTD. Good to have you here. Well, first of all, we've got the Power Clamp Air 4.0 machine. So this machine is slightly different to what we'd normally see with the contact cooling with this machine. We're actually now, this is predominantly been designed to suit ER collets. Yeah. So because we've got the air cooling system, we're able to now cool different geometries. So we've got a different varieties there of ER collets. So normally we'd see the 4-degree taper on the shrink holders, 4.5-degree taper, beg your pardon. But now we can also shrink ER collets. Yeah. What we're able to do on this machine, we've got the digital QR scanner, and we're able to now to scan a tiny little QR code here. And what that allows you to do, all the parameters then go into the machine, which are unique to this tool holder. So what we're actually doing there is making sure we extend the life of that tool. So as long as we heat and cool in the same way, we're perfect. We won't have any issues. Yeah.
And what's the advantages of being able to shrink a collet holder compared to just an ER32?
Well, it's ultimately all about efficiency. So when we're able to scan this holder here, so if you think of a mill turn lathe, yeah, you want to be in and out. So if you've got an end mill which is spent, you want to be able to take that collet out, put it back in at exactly the same length. So you're able to just put the collet in, tighten the nut, and press the button.
So it's essentially, and I know this is a bit of a stretch, but it's essentially like using a turning insert or an I-feed where you just changed it to,
it's a great
and away you go.
That's perfect. Yeah.
So then, moving on, obviously, let's move on to your Power Clamp Comfort i4.0.
Yeah.
So what's the difference between these, and why would you choose one over the other?
Well, this is predominantly, so ultimately it's got the same technology when it comes to the NG coil, the twin coil technology. But what this machine does is we cool the tool holders using the contact cooling. And what we've got on this machine, we've got the TME lights, which is a TME safety light system where obviously it's green, that's saying we're able to touch the holder. But when we actually go through the induction process and we put the cooling sleeve on, that light will ultimately go red. And there's two reasons for that. One, the first thing, is too hot, so please don't touch the holder.
We don't want any burnt fingers.
Absolutely not. But what it will do then, it will cool the holder gradually. So we don't shock the holder, we just cool the holder gradually to look after the material. Yeah.
And there's something I just want to get over quickly, and it's something I read on your website. I want to know if it's true.
Go on.
And you say that if you use the Haimer holder with the Haimer shrink fit, that tool holder could last you a lifetime.
Ultimately, yeah.
So essentially, you could. It might be a big purchase to start off with, but in the long run, it could save you so much money.
Yeah, certainly I've got a biased opinion, but ultimately I see that there's a lot of, let's call it bad press, where people say there's a life cycle to these tool holders. Used correctly, if we heat them correctly and cool them correctly, and we don't double heat and we don't misuse the machine in any way, then yes, we will say these holders will outlast.
So that's all on heat shrinking.
Yeah.
So what are we moving on to next? Because obviously we're going to get to another machine, but I just want to quickly talk about your tool holders.
Yeah, absolutely.
Because you have a system in here to help with pull-out.
Yes, this was designed with an aerospace company, I believe in the States, and it is an anti-pull-out system, and this is called the SafeLock system. So we've just got, on this occasion, we've got a power shrink holder, but what we're able to do, and there's a few companies who actually have the license to produce the SafeLock scroll. Yeah, off the top of my head, I'd love to be able to tell you, but I can't remember.
No, but it just saves that they don't essentially have to buy everything from you.
No, absolutely.
This tool holder can be used with other equipment.
Yes.
Or other
tools. Round shank suppliers. Yeah, there's only Haimer who are able to supply the actual SafeLock holder. So what you've got here, you've got the rigidity, accuracy, and the balance quality of a shrink holder.
We'll talk about balancing a little bit later on.
That's further down the line. But what we also do, when we insert this tool, obviously you'd expect this to be on the shrink machine, but as you actually insert the tool, if we rotate it quarter turn, then this spiral is obviously the reverse of what a generic cutting tool would be.
And now that tool is locked in.
So it's physically.
And essentially that's
physically impossible.
And essentially that's locked in twice now, because it's locked in by the hydraulic holder.
Yeah.
But now it's locked in by
shrink holder.
The shrink holder,
yeah.
Sorry. But now it's held in by that as well.
Yeah.
So you've got.
It's belt and braces. It's the safety belt for machining.
Yeah.
Yeah.
So obviously, tool holders, shrink fit. We're going to move on, and I just want to ask if anyone at home has got any questions for Ian.
Oh. I
have the phone in my hand to answer any of these, or get Ian to answer any of these questions, should I say?
And that's live as well, is it?
That's live, yes.
I hope there's no technical questions. We won't do technical questions.
Now, what are we looking at here, and what are the advantages of having one over not having one?
The advantage of presetting?
Yes.
Well, it's funny because we've just had a conversation with a couple of guys who, I think they had about 12 presetters, and they don't currently preset. Yeah, okay. so they had lasers on all the machines. Brilliant. So one of my colleagues said immediately, "My goodness, that's one of the most expensive presetters you've got." Because ultimately, what you're doing, while you're presetting on the machine, running it through the laser, whether it's a 10-second cycle or a 60-second cycle, while you're setting that tool on the machine,
you're wasting time.
No,
you're not cutting.
You're not cutting.
You're not making money.
Exactly.
Essentially, that everybody just wants to make money.
And why do you think they put green lights on CNC machines?
Because you want to see them running.
It's colour and money.
Yeah, I'll go with that.
Yeah, I'll go with that. It's true. So what we've got here, this is an Uno microset automatic driver. But what we've actually got with Show Tool software, and this now runs in conjunction with the Haimer microset. So the reason this has got two screens, we're trying to replicate. So this isn't how the presetter would be. This is trying to demonstrate so the WinTool software would actually be maybe in a CAD/CAM suite or with your programmer. So the idea would be so he would have the WinTool software on his desktop or on his computer. And we've got this set up for demonstration purposes. So the idea is that he's now building up tool assemblies.
So he's doing this while the machine's running?
Exactly. So what we're doing, we're actually future-proofing that process. It's a full 360-degree tool management system. So we're able to now build the tools here, give the guy the CAD drawing, the step file. It will show protrusion, even information about the actual cutting tool. So if I quickly, we've got this set up.
So what's this going to do now when you get this running?
So, well, I'll show you a couple of things. So what we've got here, so the guy in the CAD/CAM suite, he's wrote his program, he's built his tool library, and he's now built this assembly. Yeah, so he's able then to transfer this via WinTool down to the guy who's using the presetter. So when the operator comes over, he can look at that and say, right, okay, that's the tool number, that's the tool holder number, that's the tool holder number.
And also, that's how much it needs to be sticking out so I don't crash the tool holder into the part.
Exactly, yeah.
So again, you're not just future-proofing the machine shop, you're future-proofing the jobs on the machine. You're not going to have, because you know that tool needs to be stuck out this long and you need this size tool, so please build me that.
Exactly. So what we've got here, so this is new now to Haimer. This is a complete unique ID to tool holders. So what we're now able to do is, so now this is turned round. So by the end of Q2, we believe, hopefully, the QR code now is unique to that tool holder. So there's no other tool holder
so you
in the world.
Cannot get that wrong, point it in your machine?
No. So the idea is unique ID.
And the whole machine will measure itself?
Yeah.
So again, you're future-proofing every aspect here then?
Yeah, we recognise what it is. Maybe people maybe think that the skill level is sometimes decreasing. Well, ultimately what we're doing.
And the thing is, at the moment, with the skill gap and there is a skill gap, and trying to get people into manufacturing is a problem. So if you can get more things done, let's call it automated, because that's running itself. You don't need someone stood there. And also with the system being so easy to use, you could get an apprentice to run it.
Absolutely. Yeah. This is I think a huge misconception with presetting, where people think it's complicated. It's not complicated.
Well, it might be, but not for you.
Well, sometimes it is complicated for us.
Right.
Yeah.
Let's move on. So what are we going to next? Because this is the linear.
Yeah, so...
Am I right?
Yeah, so that was the automatic drive. So this is...
So we're just gonna nip past Chris quick. Sorry about that.
You saying that side, yeah?
Yeah, no, you come this side.
Okay, beg your pardon.
And then, obviously, this is... What have we got here?
So this is the Viol linear presetter.
Yeah.
But the actual construction of the machine is slightly different. This is a linear drives.
Perfect.
On this machine.
And then do we have is Olaf going to demonstrate us this while we're running?
Olaf, do you want to just...
So we'll just introduce Olaf quick.
Oh, nice to meet you.
And Olaf's going to demonstrate what this is going to do.
So what we've got here, we've got with one slight difference. So if you notice the stick out length.
Yes.
Yeah. So what we're going to demonstrate here, we're going to load a tool into the spindle, and we've got something on this machine called 3D scan. So we're able to scan now the holder and the cutting tool and the geometry of the tool and the non-cut and cutting of that tool.
So can you just quickly, for anybody who didn't catch that, can you just quickly repeat what this is going to do? Yeah,
so this now is scanning, the tool holder, the cutting tool, and once it's done that, we're able then, we'll show you where it runs in conjunction with the hide 9 control, where this is live and where we're able then to use that scan of that tool to just check that there's going to be no collisions, because when we're 3-axis machining is one thing.
Yeah.
It's 3 axes. So, but once we start rotating this tool, what we're able to show on here now, this will show you if there's any collisions, because this data now has automatically gone onto the hide 9.
Right. Okay. I get you. Yeah. So it's all right having that in your CAM software, but you can actually now have this straight onto your machine as well.
Yeah.
So
as long as it's a web-based.
Yeah.
So the best way we can demonstrate, if we just watch. So now we've got the Haimer information this side, and we've got the the hide 9 software the other side.
So now that's showing you the tool, tool holder, everything.
Yeah. So the protrusion, stick out length, part numbers.
And then that's showing you in the actual hide and hide control as well.
Scan the actual cutting tool.
Yeah.
And
then on the simulator.
So what it's actually doing now, so we've not given it any information, we've just asked the presetter to scan the tool and cutting tool. So with no input from us other than using the
And then
the
you've
scan.
just seen it as well, where it's actually run the simulation on the control to prove that tool isn't going to collide with anything.
Hopefully was caught, but I think the tool holder turns red and the machine will stop to tell you there's been a collision.
So again, you're making for that skill gap, you're actually helping people who maybe can't get a, let's say, time-served engineer. But the system is actually helping you to make sure you don't have a crash.
Well,
with ease.
It was a perfect example right from the start. So if the guy in the tool room was building these tools out and his protrusion was 10 millimeters long and he ran it through this software, the machine would tell you that it's going to collide.
So then you know you need to... So you're just making it as easy as possible for everyone. Let's be honest there.
We're making it more efficient.
Exactly.
I suppose we are making it easy. But
it is more efficient, but it's easy as well, because you're reducing any risk of a crash.
Minimising the risk.
Exactly.
100%.
So, last off, just before we finish, and I just want to say to people at home, the first time I ever interviewed Ian was on this machine.
It was, I still don't know what I'm talking about.
So tool balancing.
Yes.
Why should everybody, and let's be honest, it's still quite a rare thing to see.
It
You'll
is.
see it more than we do.
Yes.
Why should people be balancing their tools?
Well, there are two ways you can look at it. So we've recently done quite a large project in the UK where it was actually driven from a maintenance point of view. So we think as engineers that it's going to maximise the cutting tool, longer tool life, better surface finish, and. But this was actually driven by the maintenance team within this company. Because once we demonstrated it, and we said the importance of running balanced tools, they were having continuous issues with spindles. And if I told you over the last 18 months, they've spent more on spindles, and maintenance and downtime. Right? We're not saying this is the answer to all, but this is just removing one of those negative variables.
No, but if you're having problems with your spindle, because let's be honest, we've all been in the shop, we've all used, and I know we hate the word, but we've all used the R32 collets.
Yeah. But in all fairness, there's some good quality ER collets.
And everybody's always checked to see the run out, and let's be honest, they do. But to go through spindles, there's something quite major there.
There is, but this isn't, like I said, this isn't a quick fix. This is a long-term thing. If you think a balancing machine, you put it on your shop, and it could service 5, 10, 15, 20, 30 machines. You don't need one balancing machine for every machine. Yeah. So the idea is you would put a balancing machine, shrink machine, by the side of your presetter, so the last operation we know it's the final thing.
Making sure it runs right.
And all this system does, using the right information, allows you to correct the imbalance of it.
And I know you said it at the start, that it's all about surface finish and quality. We quite skipped over that, because obviously that's what you know. But I think for anyone at home who doesn't know much about balancing machines, just needs to be aware that if you've got a tool that's running right, you will get a better surface finish. You will be able to run that cutter harder than you did before.
Yeah, exactly.
You will get more out of that cutter than what you would have done before. So, of big problems it can solve. And let's be honest, if you're doing aerospace or medical, there's usually a surface, you get a better surface finish, really should be looked at.
Yeah, well, people without balancing technology and people who don't embrace it, they're not aware they've got a problem, because all they'll do as engineers, we find a solution. Yeah?
Been there, done that.
You have, something's vibrating. Why is it vibrating? Well, we don't actually know. Oh, let's tweak the data a little down, let's speed it up. Let's increase the table feed a little bit. Yeah? Or decrease it. Yeah? This is that negative variable that you simply don't know. So all this machine does is allows you to correct that imbalance. Yeah? So we at Haimer believe that every machine tool should apply a balance rating of G2.5.
Let's be honest, how many holders will hit that first time? If you've not balanced it?
Truthfully, I would be quite comfortable. I'll strip in one of these tool holders down. I guarantee that tool holder is balanced to G2.5.
But that's one of your holders.
Granted, but then, so whether it's a collet system, a SafeLock system, a shrink, once we put anything in that tool, we're changing the geometry of the tool. We're adding mass to it. Yeah. So we're fundamentally changing that. So we've no idea whether that tool is balanced.
Because essentially, you look at a tool holder and you think of it with, and we all do it. You look at a tool holder with an M mil sticking out, 30 mil. Yeah. You don't think of putting extender after extender in. But with how people want stuff designing, that's becoming more of a need now.
Of course it is.
Because people need to get into them hard to reach areas. And as soon as you extend a tool, vibration comes with the territory.
Well, listen, when you look at the advancement of full simultaneous 5 axes, as soon as we rotate this, if there's any imbalance with that, we're just shifting that imbalance to wherever that spindle's going. Yeah, but a good point you make there. So just a quick example. So we've got a 3-fluted tool there. So and we've got a centre cutting flute. So you're smiling immediately. So, right? So you've got a centre cutting flute. So there's going to be more weight.
Bang in the middle.
Bang in the middle. Yes, it's close to centre, but this software, it works out. If you're going to try and spin that at 10, 12, 15,000 revs, it works out. Well, are you able to do that? Because there's more weight on this side.
Yeah, and you want that centre flute cutting in the centre.
There you go.
You don't want to be spinning that up at 15,000 and essentially your centre's doing this.
Exactly.
Because then your surface finish is going to go, and it always comes back to the same thing. Your surface finish, your quality, how hard you can push that tool, rigidity.
Yeah.
And then, like you said earlier, you look at vibration, and the first thing you do, the work holding's not right, or I'm not holding it with the right. It's all you immediately go to work holding, when a lot of the time the work holding's absolutely fine. So, Ian, this has been my brain is going to explode. It always does talking to you. Because you are.
I do. Listen, I'm biased. It is great.
But
it is great.
It is. So I'd just like to thank you.
No worries.
And everyone at Haimer on yours.
Thanks, guys.
We're going to come this way a little bit so we can have a nice final shot of the stand. And let's be honest, if you are visiting MACH, where are we?
Hall 20, booth 446, I think.
Brilliant.
I should know that. I know
Hall
everything
20,
about that, but not the...
Stand 446. Don't miss it. And if you need any technical information, these guys will know it.
Cheers, guys. Thank you.